This is our first of two videos where we will be finding our trigonometric functions given some information. We can find the 6 trig functions using any point other than the origin on the terminal side of the angle. So that point will give us an x and a y value. From those x and y values, we can find r using the fact that r is equal to the square root of x squared plus y squared. Then we'll simply plug x, y, and r into our 6 trig definitions. So let's find the values of the 6 trig functions for each angle in standard position having the point -4, -3 on the terminal side. Well, this ordered pair gives us our x and our y value. We need to find our r value. And we're using the fact that r is equal to the square root of x squared plus y squared. So r is going to be equal to -4 squared plus -3 squared. That'll be the square root of 16 plus 9, the square root of 25, which is 5. We have our x value, our y value, and our r value. That's all the information we need to be able to do our 6 trig functions. Sine of theta is defined to be y over r. Cosine of theta is defined to be x over r. And tangent of theta is defined to be y over x. We're simply going to take the x, y, and r values that we have, 2 that were given, 1 that we found, into these definitions and then simplify. So sine, that's going to be y, which is -3 over r. So sine of theta is -3/5. Cosine of theta is going to be -4 over 5. And then tangent of theta, that's y over x. That's -3 over -4, which we can simplify to be positive 3/4. So those are like our 3 mains. And now we need to get the other 3 trig functions. As I mentioned in the previous video, I always try to pair them up with the ones that their definitions are the reciprocal. So the one that is the reciprocal with sine is cosecant. Cosecant of theta is r over y. The one that's the reciprocal of cosine is secant. Secant of theta is defined to be r over x. And then our last one, cotangent of theta, is defined to be x over y. Now you are welcome to go back to our original point and our r and just plug it in. Right? So I'm going to do r, which is 5, over y, which is -3. And maybe that's what you should be doing right now as you're first learning this. But in practice later, I would strongly encourage you to just say reciprocal and flip over the fraction. You know, this next one's going to be 5 over -4 because it's the reciprocal. You want to get to that point even if that point isn't today. So I'll use the definition here again. Secant is r over x. So that's going to be 5 over -4. And then for cotangent, we have x over y, which simplifies to be positive 4/3. Let's try another one. Exact same idea. This is the only way we do these problems. They've given us an ordered pair, so this is our x and our y value, and we need to find r, where r is equal to the square root of x squared plus y squared. So it's going to be negative 2 square root of 3 squared plus negative 2 squared. Because the operation between the negative 2 and the radical here is multiplication, we can just square the negative 2 and square the square root. That's going to give us 4 times 3 plus negative 2 squared is 4. It's going to be 12 plus 4. R is the square root of 16. Which simplifies down to 4. Now that we have our x, y, and r values, all we need to do is plug it into our definitions. And I would encourage you to write out these definitions just over and over again every time you do a problem until you have them locked into memory. So sine of theta is equal to y over x. No, it's not. It's equal to y over r. Cosine of theta is equal to x over r. And tangent of theta is equal to y over x. So plugging our numbers in here, it's going to be negative 2 over 4. Simplifies down to negative 1/2. X over r, that's going to be negative 2 square root of 3 over 4. And we can simplify the 2 and the 4 both on the outside of the radical. This becomes negative 3 over 2. And then for tangent, y over x, it's going to be negative 2 over negative 2 square root of 3. Well, we can simplify this by canceling out the 2's, but then we have 1 over the square root of 3, and we're going to want to rationalize that. We end up with tangent of theta being square root of 3 over 3. Now that we have our first 3, we can get our other 3 easily because they're going to be the reciprocal. The function that's the reciprocal of sine is cosecant. It's going to be r over y. So I'm just going to do the reciprocal of negative 1/2 and get negative 2. The trig function that is the reciprocal of cosine is secant of theta. I always remember because I feel like secant looks like cosine written backwards. And I always remembered that those two paired up. And then I thought it was kind of obvious that tangent and cotangent paired up. And so that left secant, cosecant to be with sine. All right, so secant is r over x. That'll be negative 2 over square root of 3, and we'll rationalize this. We'll get negative 2 square root of 3 over 3. That's our secant. And then lastly, cotangent. That's x over y. Now I've been just doing the reciprocal of our answer. However, our final answer here we got by rationalizing. And if I do the reciprocal of this one, I'm going to have to rationalize again. So you actually want to do the reciprocal of what you had before you rationalized it. That'll give us the square root of 3 over 1, which is just the square root of 3. And that gets us out of having to do an additional rationalize and simplify. So if we're given 2 points, we want to find r using the fact that r is equal to the square root of x squared plus y squared, and then just plug them into the definitions for our 6 trig functions that we have practiced really hard to remember. All right, one more. Sometimes 0 can make things seem a little different, so I wanted to make sure to do an example with a 0 in it. But the process, exactly the same. Here's x, here's y. R will be the square root of 5 squared plus 0 squared. We get r to be 5. And then on to our definitions. Sine of theta is y over r. So that's going to be 0 over 5. And 0 divided by 5 is 0. Cosine of theta is defined x over r. So that's going to be 5 over 5, which simplifies to 1. Tangent of theta is defined y over x. So that's going to be 0 over 5. We get tangent of theta to be 0. And then the next 3 are reciprocals. The reciprocal of sine is cosecant. That's r over y. Now, if you're going to take the reciprocal of your final answer, make sure that you're, turning them into fractions when you flip them over. It might be easier to flip over the step before, like these ones. Oh, cosecant is going to be 5 over 0. And remember, a 0 in the denominator of a fraction is always an issue for us in math. That makes our fraction undefined. So for this ordered pair, cosecant is undefined. The reciprocal of cosine is secant. It's our r over x. 5 over 5 still simplifies down to be 1. And lastly, cotangent of theta is equal to x over y. It's going to be 5 over 0, and we've got that problem 0 in the denominator again. Cotangent of theta also undefined. So just be careful. It's so easy to, mix up that if 0's in the numerator or the denominator, which one's undefined. So in the denominator is the one that's always the problem. The next thing I'd like to do is suppose that a given point is in an indicated quadrant, and I want you to decide whether the ratio that's being asked about is positive or negative. And it'll depend on which quadrant we're in. All right, so we have a point that's in quadrant 3. We're here in quadrant 3. And remember that quadrant 3 the x value is negative and the y value is negative. Note that our r value is always positive. R represents the distance from the origin to our point. And we never talk about distances in terms of a negative number. So our R value is always positive. But in quadrant 3, both the x value and the y value are negative. So if I'm asked about deciding the sign of the ratio, well, if the x value is negative, and I'm going to divide that by the y value that's also negative, that's going to lead me to a positive. In our next example, we're going to be in quadrant 4, and we want to decide whether y over r will be positive or negative. So I always like to draw a picture. So I'm somewhere in quadrant 4. In quadrant 4, the x value is positive and the y value is negative. Right, so I want y over r. Y is negative in the 4th quadrant. R is always positive. If I take a negative and divide it by a positive, it's going to leave us with a negative. Knowing whether a ratio is positive or negative is going to prove something important for us moving forward.